Hello there, integrated science students, and welcome to our last video lesson for Unit 3, Earth's Materials. We are going to examine metamorphic rocks and the rock cycle inside of this video. Okay? So our last group of rocks, and then the process of how we are always reorganizing matter within Earth's geology to create different rocks, okay? To create different material. Alrighty? 4 video topics for this lesson. Alrighty? First thing we're going to look at is the definition of a metamorphic rock. Then we're going to talk about how metamorphic rocks form. So we'll look at the formation. Second video topic there. Our third video topic is going to be all about the types of metamorphic rocks. Okay? Classification. Alright? And then finally, our fourth topic is going to be the rock cycle. A real quick little glimpse at how we are constantly seeing change over long periods of time from one form of rock to another, and then back to it, and then maybe to another, and then back to another one. Alrighty? Without further ado, let's go ahead and let's knock out video topic 1. Metamorphic rocks are rocks that form when existing rocks undergo extreme heat, pressure, or chemical reactions. Metamorphic rocks are formed from pre-existing rocks. So you have to have a rock already. It could be an igneous rock, a sedimentary rock, or an already formed metamorphic rock. Okay? A metamorphic rock is a rock that undergoes a change because of heat, pressure, or chemical reaction. Alright? Now there's a couple ways that can occur, and we're going to get to that in a second, but I want to break down just the term metamorphic for you. The root word meta means to change. Morph means form. So literally right there in the definition, you've got it saying what it is. It is a rock that's changing form. Okay, a metamorphic rock, a rock that has changed form. It's got to be a pre-existing rock. It's undergone heat, pressure, and chemical reactions. It's changed. Okay, both physically and chemically. Still all about the composition and texture though. Just like with igneous and sedimentary rocks when we were kind of defining them, it's all about the composition and texture. And we're going to see that here later in the video as well. Okay? But metamorphic rocks, rocks that have undergone some type of change, physically and chemically, due to changes in heat, pressure, and chemical reactions over a long period of time. Okay, formation. Video topic 2, formation of metamorphic rocks. Kind of already got a little bit there with the definition. Okay, how do you form a metamorphic rock? Well, you need some heat. All right, you need maybe an adjustment in pressure, and you need the potential for a chemical reaction to take place. Now, there are typically 2 areas at which metamorphism, the changing of rock form, does take place, and we call one of them regional metamorphism and the other one contact metamorphism. Regional metamorphism is usually caused by a large movement and burial or adjustment of a rock area due to tectonic plate movement. Okay, so you got yourself a big chunk of rock, tectonic plate movement, large amounts of burial, large amounts of change in temperature, pressure, and large change to that entire area of rock. Okay, contact metamorphism is a little bit more specific. It's not nearly as widespread or broad. Essentially what you have is you have some type of maybe flow of magma through the Earth's crust, okay? And over time, metamorphism has taken place within the rocks that are close to that magma flow because of the additional heat that magma may have ingested into that area. Okay, so contact metamorphism, a little more specific. Regional metamorphism, very broad, very large due to large movements of tectonic plates. So whether it's regional or contact, the heat, pressure, and chemical reactions that are taking place form the metamorphic rocks. Make those pre-existing rocks, whether they're sedimentary, igneous, or metamorphic, change into a metamorphic rock, a certain type of metamorphic rock. Now, the chemical reaction is kind of the major player at this. Pressure can kind of realign some of the mineral grains. All right, it can kind of realign some of the sediment pieces. All right, heat is kind of going to again allow a lot of bonds to be broken. All right, to kind of go maybe from that solid to that partial solid to somewhat of a liquid state. But it's really the chemical reaction that's making the biggest change here for the metamorphic rock, and it's a chemical reaction that takes place due to the presence of water. Almost every single one of these metamorphic rocks that we're going to talk about have had at one point in time water within their crystal structure. So if you start to heat and pressurize that initial rock, water's not really a fan of that. The real change to the pre-existing rock to become a metamorphic rock occurs when the water is adjusted. All right? The water is escaping or realigning or doing work on some of the previously crystallized minerals and then giving us a different metamorphic rock. The length or duration of metamorphism has a big impact as well on what type of metamorphic rock you get. And I'm going to have a table up in the video here in a second when we start looking at the different types and classification of metamorphic rocks. But that table is also on page 832 in your textbook, and I suggest that you go ahead and take a gander at it. Okay, classification and identification of metamorphic rocks. Two major groups, foliated and non-foliated metamorphic rocks. All right, foliated metamorphic rocks mean that you have some type of lineation, all right, some type of banded appearance. What's usually happened is throughout the chemical reactions taking place in metamorphosis, you've got a greater amount of pressure, and the specific materials that make up that metamorphic rock have now realigned themselves in a type of linear, almost sediment deposited like fashion. Okay? Non-foliated texture is a random placement of the now newly crystallized minerals and sediments that are forming that metamorphic rock. So foliated, you see some bands and some lines. Non-foliated, absolute random crystalline structure and placement of the sediments and of the minerals that make up that rock, that metamorphic rock. And at times it can appear uniform completely in color and appearance. All right, so those are the two different textures that we're going to look at. Now, I talked to you about that diagram I said I was going to put up, and I'm going to put it up now. And I want you to take a look at how we've got the two groups. So on the left side here, we've got foliated and non-foliated. We talk about the texture, of course, being layered or banded, and then fine-grained, coarse-grained, coarser-grained, and the composition. So what minerals may be present, and then what rock type that may be associated with the presence or non-presence of those minerals. Again, some of those minerals form larger crystals or form in general to where you can see them through an increased length in the metamorphic rock forming process. Okay? So the differences in metamorphic rocks that we see, it's really all about the degree of differences, I should say, is all about the length and duration of metamorphosis. Alrighty? Kind of similar to igneous rock formation. You got larger crystals as that magma or molten rock could cool for a longer period of time. Same thing with metamorphosis. The longer it takes place, the larger crystals you get, the different rock that is formed. Okay, so we've knocked out the 3 video topics dealing with metamorphic rocks. We should feel comfortable about the definition of a metamorphic rock. We should feel comfortable about the formation of metamorphic rocks, both regional and contact, and how it's all about water being present to help assist those chemical reactions and assist in realigning and recreating some mineral crystalline structures. And then we talked about classification, with the 2 major groups being non-foliated and foliated, and the degree of difference between the metamorphic rocks directly being associated to the length of metamorphism, all right, and the duration of metamorphism for that rock. So we've gotten those 3 topics out of the way. Now let's look at the rock cycle. All right. Matter is neither destroyed or created. All right. Matter cannot be created nor destroyed. It can only be reorganized or rearranged. And that's what we see taking place with the rock cycle. Whether you're starting with igneous, sedimentary, or metamorphic rocks, each one of those could be transformed into another one of those types of rock. So igneous rocks could actually melt, be buried deep under the earth, melt, and then recrystallize as an igneous rock. An igneous rock can become itself again. Alrighty? A metamorphic rock could be further buried, undergo metamorphosis, and become a metamorphic rock again. Metamorphic rocks, sedimentary rocks, igneous rocks could all be exposed to the weather and the climate and the physical conditions up here on the surface of the planet, and all of them could be weathered, eroded, transported, deposited, compacted, and cemented and formed into sedimentary rocks. All right? A sedimentary rock and a metamorphic rock could be buried deep underneath the earth, melt into molten rock material, and then form and recrystallize as an igneous rock. So it's all connected to one another. Alrighty, all connected to one another. Each one of the rock types could be broken down in a process that then reforms itself again in a different fashion. And each one of them could take a path to become a metamorphic rock, and each one could take a path to become a sedimentary rock. You just got to be consistent with the processes that take place and how you get to a couple of middlemen, if you will. One of the middlemen being molten rock material, and the other one being sediments. Okay? The middleman to form a metamorphic rock is the rock itself, the pre-existing rock itself. But you do have to recognize and know that in order to get a sedimentary rock, you need sediments first. In order to get an igneous rock, you need molten rock first. Okay? So if you know the three types of rock, you know the two middlemen, molten rock and sediments, and you know some of the general processes of how each one form, which we've covered in these videos, you'll be able to fill out the rock cycle, trace the lineage of any rock, and describe for me how we are not creating nor destroying matter, but just reorganizing and rearranging it. That does it for this video lesson. Email me, tweet me, contact me if you have any questions, and I'll see you guys in class. Adios.